So in the previous example, we had a set of equations, three variables, which had a single solution. Now let's consider this set of equations and see what the solutions are. We take the augmented matrix here, which is equal to 1, 1, 3, 1, 3, 2, 8, 4, 3, 3, 9, 3. Now I already have my 1 in the top left corner, so I'm going to create zeros in these positions, and I can do that by subtracting the first row 3 times from the second row, and also subtracting the first row 3 times from the third row. The first row stays the same, 1, 1, 3, 1. 3 minus 3 is equal to 0, 2 minus 3 is equal to minus 1, 8 minus 9 is equal to minus 1, and 4 minus 3 is equal to 1. The third row, 3 minus 3 is equal to 0, 3 minus 3 is equal to 0, 9 minus 3 is equal to 0, and 3 minus 3 is also equal to 0. And we see we have a rows of all zeros. Well, let's still tidy this up. I will write out this set of equations again, but I will multiply the second row by minus 1 to get a 1 there. 1, minus 1, 0, 0, 0, 0. Now, I can't get a 0 here because I'll never get a 1 there, but I can get a 0 here. I want to get a 0 here. And I can do that by subtracting the second row from the first row once, and I get, well, the third row is unchanged, the second row is unchanged, and I get 1 minus 0 is 1, 1 minus 1 is equal to 0, 3 minus 1 is equal to 2, and 1 minus minus 1 is equal to 2. And I have a row of zeros, so I know I have infinitely many solutions, and I will write out these equations. I have x plus 2 times z is equal to 2. I have y plus z is equal to minus 1. And the last one, I just write z is equal to z. I will change this set of equations to x is equal to 2 minus 2 times z. Y is equal to minus 1 minus z, and z is still equal to z. And I can write out the solution in the following way. X, y, z is equal to 2 minus 1, 0, plus z times minus 2 minus 1, 1. And we can see here, again, this is a line where this is a basis and this is the direction vector. And this will be a line in 3D space. And so I already knew here I had infinitely many solutions, and this is a way of showing it. And I think this pen has pretty much had it. Let's take a nice fresh one. The book will write this as, well, it will basically take, you end up in this point, and the book will write x is 2 minus 2t, y is equal to minus 1 minus t, and z is equal to t. It just replaces that z by t, but in essence it's exactly the same solution. We have a line in 3D space. So if we have one row of zeros, we have one variable which we have no information about. And in this case, I mean, I've written it as z, but we can rewrite this equation so that x is the free variable, y is the free variable. The important thing is we have one free variable. But you can also you can also have two free variables. If we take, for example, the equation, what is it, x minus 2y plus, z is equal to 3, but we then have no other information for this set of equations, we can write this as 1, minus 2, 1, 3, but zeros everywhere else. And the augmented matrix of this equation, this single equation, which does end up as a plane, is this. And this would yield x minus 2y plus z is equal to 3, y is equal to y, and z is equal to z. And if we rewrite this as, well, just the way we did here, so x is equal to 3 plus 2y plus z, minus z, y is equal to 0 plus 1 times y plus 0 times z. That's basically rewriting this in a very elaborate way, which we'll also do for this, plus 0y plus 1 times z. We get the solution x, y, z is equal to 3, 0, 0 plus y times 2, 1, 0 plus z times minus 1, 0, 1. And we see that we have two free variables. So this is not just a line like we have here. No, we have variability in 2 dimensions, and this will yield a plane in 3D. So if we have one row with all zeros, we get one free variable and we get a line in 3D. If we have 2 rows of zeros, we also have infinitely many solutions, but the solution is a plane in 3 dimensions. So we know what it looks like to have a single solution, and we know what it looks like to have infinitely many solutions. And of course, if we have 3 equations and 3 variables, the solution set, if it's infinite, it can be a line or it can be a plane. All right, and then so we only have one more example to go where we have no solutions, and I'll show you that in the next part.